Static in DTF printing is difficult to understand because the film usually looks normal. You load the same roll type, the print settings are the same. The printer is running normally, but as production continues, the behavior starts to change. Powder may distribute less predictably. Fine particles may cling where they should not. Film handling may feel less stable. Local inconsistency may appear even though nothing obvious has changed. This is why static is often misdiagnosed. Static buildup is not a scratch, coating mark, or visible material defect. It is invisible electrical charge on the film surface. Once the change exists, the film is no longer just a passive surface. It becomes part of an electrostatic system. The manufacturing question becomes, is the film electrically stable while it moves through the process? Static builds up because DTF film is consistently moving and consistently interacting. During printing, the film contains rollers, guides, feed component, air, and sometimes on the film layers. Each contact and separation event can transfer electrons. This is the same electrostatic principle seen in many material handling systems. If charge cannot dissipate quickly, it remains on the material. In DTF printing, that material is a moving film web. The film experiences this repeatedly, roller after roller, guide after guide, movement after movement. So static is usually created by a repeated interaction across the film path. The film material matters because not every surface releases charge in the same way. DTF film is a layered structure. It has a base film and a printable surface for ink deposition, powder adhesion, curing, and transfer. Those layers are not designed to behave like metal conductors. If the surface have limited conductivity, charge may not spread or disappear quickly. It can remain in certain areas. Surface properties affect how charge is generated, how it moves, and how easily it dissipates. A film can look normal and still carry a different electrical state from one area to another. You may not see the charge. You see what it does to powder, particles, droplets, or film handling. Environment is one of the strongest variables in static behavior. Under low humidity, static becomes easier to build and harder to release. Dry air provides less conductive pathway for charge dissipation. In a dry production room, charge generation may continue while charge dissipation stays weak. That imbalance is the real issue. Static builds when charge generation is greater than charge dissipation. Higher humidity can help reduce static because moisture improves charge leakage, but humidity should not be uncontrolled or simply pushed higher. DTF printing still depends on stable ink, powder, drying, film handling, and transfer behavior. The lesson is stability. A dry, uncontrolled room gives static more opportunity to persist. Static can also increase during a run. At the beginning, the film may appear stable. As it keeps moving, the system keeps generating new charge. If there is no active path to neutralize or redistribute charge, it may not disappear by itself. The machine is still feeding film, creating contact, separating surface, and production friction. So the process may not settle down. It may become more unstable over time. This is why static-related behavior can appear during long runs, higher speed operation, or repeated film movement. The setting did not change. The electrical state of the system changed. That distinction matters. Static does not always spread evenly across the film. One air may contact the roller with different pressure. One edge may experience more friction. One zone may retain charge more easily. Because of surface condition, airflow, or contact history, the result is a localized charge accumulation. Localized charge creates localized electrostatic influence. One part of the film may attract fine particles more strongly. Another may repel them. Another may behave almost normally. So the print result may show patches, bands, edge instability, irregular powder behavior, or inconsistent material interaction in selected areas. If one whole parameter were wrong, the defect might appear more globally. When static varies across the film, the result can vary across the print. Electrostatic force adds another layer of behavior. In a stable system, powder particles fall, contact wet ink, and distribute based mainly on gravity, mechanical motion, particle properties, and surface interaction. When the film is charged, that changes. Powder particles are small and light, so electrostatic force can influence where they move, settle, and cling. A charged surface can attract and repel fine materials. It can also make particles behave differently from one air to another because the charge field is not uniform. This is why static is connected to powder instability. The powder may look like the problem, but it may only be responding to an electrostatic condition created earlier. Static buildup is not automatic proof that the film is defective. It is not only an ink problem, only a powder problem, or caused by temperature alone. It usually cannot be solved by changing one setting while ignoring the rest of the system. Static is the relationship between material, movement, environment, and dissipation. If film generates charge faster than the system releases it, static builds. If charge becomes localized, process behavior becomes uneven. If fine particles enter that charged field, powder behavior can become unstable. So the troubleshooting mindset has to move upstream. Do not only ask what changed is the powdering unit. Ask what electrical condition the film carried into that stage. Static build up on DTF film because printing continuously creates opportunities for charge generation. The film moves, it contacts rollers and guides, surface is separate, electrons transfer. The film may retain charge, lower humidity, may prevent dissipation. Long runs may allow accumulation. Local conditions may make charge uneven. Once static is present, the film surface is no longer electrically neutral. It becomes an electrostatic field that can influence droplets, powder particles, dust, feeding behavior, and the downstream stability. The manufacturing lesson is simple. Stable settings do not guarantee stable printing if the electrical state of film is changing. To understand the static, look at the full system, film surface behavior, machine movement, contact points, humidity, dissipation, and powder interaction. That is how DTF troubleshooting moves from reacting to the symptoms to controlling the process.